Okay. Hello friends, in this video again I will start to solve this question which comes in many examinations, JEE Advanced and IIT JAM, even CSR NET, this question also asked. First of all, I am trying to solve how can you solve such kinds of problems. This question is given limits n tends to infinity e to the power n divided by n factorial. It looks very easy questions as an expression because there are only two terms. But when you will solve, you will feel something different in these questions. And if you are trying, there are two methods to solve such a question. But I will give only one method that will help to quickly solve these questions. And there is a formula that will help to solve this question, which is called Stirling formula. Now, first of all, I am trying to give how can you solve. One of the important formula which is called Stirling formula, please remember it, Stirling formula. Now, what is Stirling formula? Stirling formula is n factorial is equal to under root 2 pi n into n by e whole to the power n. This is the formula of Stirling, which is very important to solve this question. If you know this expression and formula, you can solve these questions very easily. If you try to take some important and some standard calculation way. Now, I am trying to solve this question with the help of this formula. Now, can you write this expression limits n tends to infinity e to the power n upon n factorial means that under root 2 pi n into n by e whole to the power n. Can you write as it? Now, a second point in this question, you have to write at limits n tends to infinity. If you take e to the power n, which is came in denominator of denominator, after calculator it will be given numerator. So can you write e to the power n whole to the power root under 2 pi n into n to the power n. Now it looks some easy and different format. Now rub this smart and see here it will be limits n tends to infinity. Now e to the power n, e to the power 2n, here this is given n to the power n. Can you write as 1 upon under root 2 pi n into e square upon n whole to the power n, e square upon n whole to the power n. Now, one important thing that I want to discuss with you, if you see this expression, what will happen? First of all, I want to explain here. I want to see this expression. If you go through the calculative manner, it will become very complex calculation. So here you have to see only dominant terms in this expression. If you see in this expression, dominant expression looks this section only. So we will try to solve only this section firstly. When n tends to infinity, what will happen with this law? See here, e square upon n whole to the power n means that when n tends to infinity, definitely e square is a number, and this is your n terms. And when e square and n here is trying to approach infinity, when it will approach to infinity, definitely whole term what will happen, because e square is almost 9, this is number between 9 and 10 because e 3 point something, and if you put 2 point something, and if you put here, it will give you almost numbers that lie between 4 and 5, and if you calculate e square, that means it is a fixed number divided by a number which is approaching to infinity. Definitely if you divide this number by infinity, it will approach to 0, and if it approach to 0 and 0 to the power something that is very big numbers, so it will definitely approach to 0. Now in this expression, this term is dominating terms, and otherwise it is very small terms because root under 2 pi, which is you can calculate, and this is also terms that can help to calculate, but it will again 1 upon infinity format, which will give again 0. So overall, if you see here in this expression, you will get 0 because this dominating terms is here trying to approach 0. So you can see this looks very easy and short questions, but it's very complicated during if you go or you're trying to solve with the help of formula or its exponent, that means n factorial. If you trying to write n into n minus 1 and n minus 2, it becomes more complicated. So trying to always solve this question with this method. Thank you, and again in this next video I will try to solve another questions.